Good morning, everyone. Thank you for joining today's Datagaps webinar. We are excited to dive into our topic, which is streamlining Power BI with DevOps, automating testing, CICD, and analytics delivery. Throughout the session, you will see a few poll questions appear on your screen. We encourage you to participate in those as they come up. If you have any questions at any point, please enter them in the Q&A section of the AI Meet platform, and we will address them during the session. Joining us on today's panel are Anand Rao, Vice President of Marketing at Datagaps, and Pradeep Napa, Lead Solution Engineer. Over to you, Anand and Pradeep.
Thanks, Sushant. Hello, everyone. Thank you for joining this session today. Welcome. If it's the first time you're interacting with Datagaps, welcome to our webinars. This is a bi-monthly webinar series that we have a lot of audience who are participating. And in this specific session, we'll show how Power BI teams can deliver accurate, stable, and trusted dashboards without slowing their development process. So many dashboards fail, not because of all the skill gaps that are present, but because the changes move too quickly across all the dev, test, and production environments without enough validation. And so by the end of this webinar, you'll understand why manual checks of these dashboards aren't enough and how you could automate this process, integrate it with your CI/CD systems, and improve the reliability and the practical adoption of these dashboards. So here's what we'll cover today. We'll start by discussing why business intelligence deployment needs to be modernized, especially in the context of Power BI and all the DevOps capabilities that are out there. And many organizations still rely on manual, fragile workflows that slow releases, basically. And next, we'll walk through some of the Datagaps capabilities here. Pradeep, who's going to be co-hosting this webinar, will show how automated validation supports the CI/CD pipelines. And then we'll share a couple of customer metrics to demonstrate the impact such a process will have. And after that, we'll see how this whole automated testing is in action. And we'll close with a checklist, some key takeaways that you can have following this webinar, as well as next steps. So why does BI deployment need to be modernized? As many of you are aware, BI has changed significantly over the last few years. Dashboards are no longer these static reports that update once a week. They're all dynamic, interactive assets that support daily and sometimes hourly decision making. So as a result of all this, changes happen more frequently, and the cost of errors is much higher. So in spite of this shift, many teams still deploy Power BI reports using largely manual processes, and a report is downloaded, modified, and then republished across different environments. And without modernization, teams remain in this reactive mode, fixing issues after deployment instead of preventing them. And this leads to a lot of firefighting, lost trust in the dashboards, and overall slower innovation because you might have to roll back these pushes. So BI delivery has to evolve to match the importance and the complexity of the insights it provides. To illustrate this, so at the core of many Power BI challenges is the gap between publishing those reports and the quality control of those reports. So Power BI makes it easy for everyone to move reports between environments, but it does not enforce how these changes are reviewed or tested before promotion. So as a result, many teams rely on the manual steps. You download the PBIX file, you update the connections for dev, test, and prod, and republish. So governance becomes based on hope rather than evidence. So meanwhile, Power BI itself is getting smarter every day. We have AI visuals, Copilot assistants, and all these advanced predictive models. But the value of those innovations flatten if the deployment process remains manual and fragile. So this creates the operational risk. You have inconsistent workspaces, broken visuals, reaching production, and confusion over who changed what. So the numbers are pretty telling over here. So manual deployment can drive error rates up to 18%, while a mature automation brings that down to 2%. So many of these failures are from simple human errors, overwriting reports, misconfiguring data sources, and such kind of things. But automation alone is not enough. So moving these reports and content faster without validating it only makes the risk move faster. So the solution is DataOps with CICD. So adopt that the PBIP for version control, use Git and the pull request, introduce automated quality gates to validate the data, the logic, the performance before deployment. So here is a slide where that explains why Power BI collaboration has remained limited for so long. So the traditional .pbix file is this single monolithic binary file because it's opaque. Modern version control tools like Git cannot meaningfully compare the changes inside it. So you can store it, but you can't truly diff it. So that creates three major problems that I've highlighted here. First is the collaboration risk. So when multiple developers work on the same report, they can easily overwrite each other's work, and development becomes sequential instead of parallel. And then there's this whole traceability gap. It's difficult to answer who changed what, changed, etc. And rolling back one specific logic change is quite hard and close to impossible. So the third, teams fall back to this messy file versioning. So you have report underscore versioning 3 underscore final. So you're instead of maintaining a proper trail that's suitable for an audit, you have these kind of naming conventions. So the move to the new format changes this, and I'll tell you more about this. But along this, there is visibility is not validation, and the new format provides visibility. And let me talk about that new format. But before I get there, there's the cost for all this manual firefighting. So manual deployment introduces risk at every step of the Power BI release process that I highlight here. Each time a PBIX file is downloaded, modified, and republished, there's a potential for configuration drift, incorrect connection strings, or credential issues. So these problems often surface only after users encounter those broken dashboards in production. So this creates all this fragility, inconsistency, and human error, and dev, test, and prod environments drift over time. So a test version can overwrite a production version, a report or data set ID may change, breaking those bookmarks and application links. And with no reliable rollback method, teams are forced into this firefighting mode. So the impact is measurable. Organizations relying on manual deployment, as I said, experience a far higher error rate of 18% compared to 2% for this automated process. And Gartner estimates that poor data quality costs organizations an average of 12.9 million every year. So this is not about individual mistakes, they are systemic. So the solution is not to be more careful, but redesign the process where you automate with validation and you have the support of all the CICD and the quality gates. So there has to be this mind shift change, and you have to treat Power BI assets like software code, not static finished files. So in a modern DataOps workflow, reports are saved in PBIP format, turning that report into and the semantic model into a text-based file that can integrate with Git repositories, and every change becomes tracked, reviewed, and reversible. So development on the top left. So development happens through these pull requests. If you're from a DevOps background, you probably are very familiar with this, where changes are proposed and viewed with context. So instead of relying on the trust or spot checks, reviewers see exactly what happened and why. And while human judgment still matters, but it is supported by all this evidence. So next on the top right is validate. So automated checks run early in the life cycle. This is the whole shift left approach, where the CI pipeline performs the schema validation, the best practice checks, and the functional tests before anything reaches the user. Then comes the deployment. So you have a gated CI/CD pipeline that promotes these reports across environments in an auditable way, automatically applying the correct data source and security roles. And finally, you want to monitor using DORA metrics. So you want to monitor deployment frequency, lead time, change failure rate, and mean time to resolution to measure the improvement this process gets you. And the result is speed with safety. So you have fewer incidents, safer rollbacks, and more time delivering trusted insights instead of all this firefighting. So let's dive in a little bit into this new PBIP format, which is the catalyst for modern Power BI delivery. So unlike the legacy PBIX binary file, so PBIP breaks a project into structured text-based artifacts, making the BI assets manageable like code. So with all the TDML integration, the semantic model measures, relationships, and metadata become all human readable and compatible with Git-based version control. So this enables all the granular tracking. Teams can view line by line differences, review the changes in the pull requests, and revert any commits when needed. So PBIP also supports all this parallel development, allowing different team members to work on the model and visuals without overwriting each other. So, however, when you have this visibility, it's not validation. So a change that looks correct in a diff report can still produce incorrect results in the real reports. So while PBIP enables traceability and collaboration, it does not guarantee correctness. So PBIP makes the modern delivery possible, but the broader DataOps framework is required to make it reliable. So here is a practical CI/CD pipeline for Power BI. So you build reports locally in a Power BI desktop, but save it as PBIP. So the project can be decomposed into human readable files, TDML, such as TDML, and it's compatible with the Git version control. Then you commit and do a pull request. So you follow the standard Git workflow of doing a feature branch. You commit, you push, and you open a pull request. And the pull request becomes the trigger for automated checks. And then finally, after the automated checks are complete, you have a quality gate. So the CI continuous integration pipeline runs automatically on the pull request. It performs the schema validation, the best practices, the logic tests using different tools. And then the automated validation checks the data accuracy, the logic correctness, as well as the visual behavior of those reports. And you attach the results to the pull request, showing the evidence in order to either approve the change or deny it. So after approval, the CD pipeline promotes those assets across dev, test, and production, and it applies the consistent environment-specific configurations. So all the connections, credentials, the security roles are all applied, and the result is a predictable, repeatable release with fewer surprises. So this whole concept of shift left testing means you're validating the changes as early as possible in the life cycle before it reaches production. So, and you do this so that instead of reacting to failures after deployment, the team catches the issues during development when they are easier and cheaper to fix. So in a DataOps workflow, there are three core validations that drive this model. First is the best practice analyzer. It enforces the standards such as consistency in naming, performance patterns, or efficient DAX logic. Next is schema validation, where you're confirming the tabular model actually matches the source database, preventing any kind of refresh failures or broken visuals caused by any kind of changes upstream. And then you have the reference integrity checks, where you validate the relationships between the tables through the keys to avoid any incorrect results. So the key benefit is you have all this early objective feedback. The testing becomes repeatable, it becomes automated, replacing all these manual inspections. And it's a continuous validation practice, so increasing the confidence and keeping the production stable. So Power BI dashboards rely on multiple interconnected layers. So the data sources are at the bottom, the semantic logic, the visual behavior, and then you get the performance and security. So at the data source level, you're confirming the connectivity, the success of the refreshes, the row counts, and the relationship integrity. And so this prevents any kind of stale data and any kind of upstream schema changes from breaking your reports. The second is your semantic logic testing, where you're validating all the calculations in the DAX layer, your measures, your business rules, and ensure that these KPIs remain accurate. The third is all the visual functionality testing, where you verify the filters, the slicers, the drill downs, and the bookmarks. And all these automated visual regression testing compares the screenshots against known good baseline screenshots to detect any unintended changes. And then finally, the topmost layer is the testing in the real world conditions for integration and performance, where you are testing the stability, the embedded scenarios, any kind of API results, and row level security. And you're also doing performance checks of these dashboards and how they scale under different load conditions. So the goal isn't, perfection, but it's this consistent coverage of the tests. Uh, so again, on the manual side, we see four common problems. The manual publishing can overwrite a report and data set IDs, which creates this instability. It can break user bookmarks, disrupt saved views or application links. Third, it requires manual parameter entry, which introduces the risk when updating connection syncs across different environments. And then finally, there's no audit trail, making it difficult to track who deployed these reports, when did they do that, and so on. So in contrast, on the right side, you have the pipeline deployment that addresses these issues. It preserves the report and data set IDs. It maintains the stability. It retains the bookmarks and the application links. It protects the user experience. It can swap automatically the connection strings, such as SQL underscore dev could be one string, and it can swap it to SQL underscore production, reducing all those manual errors. And it provides the full deployment logs. So you're creating that traceability and accountability. So the last piece was about monitoring. How do you know that Power BI delivery process is actually improving? So first is the deployment frequency. This shows how often we can safely release the report and those model changes. So higher frequency signals more automation and safer releases. Second is the lead time for changes. So this measures how quickly a committed change in the Git actually reaches production with CI, with all the validation and automated promotion. And the third is change failure rate, and this reflects the quality, the percentage of deployments that cause any kind of production issues, such as either a refresh failure or broken visuals. So all these quality gates help lower this failure rate. And finally, you have the mean time to recovery. So, and this measures the resilience. So if there is an error, how quickly can we restore the service when something breaks? So with all these Git-based assets, recovery can mean reverting those commits and redeploying. So the key message is, you achieve velocity through automation and maintain the stability through validation. So in terms of maturity, there's the whole bottom level, the first level, where you're relying on the manual PBIX files. You have no version control. Deployments are risky. Issues are fixed after they break. The second, so you're reactive there. The second is managed, where the teams are introducing Git for versioning, changes are tracked and auditable. Deployment still remains manual, but collaboration, improves, but still risk exists in the promotion stage. Third level is the proactive, where teams are implementing these automated pipelines and basic testing. CICD introduces all these validation steps, reducing the errors before they reach production, and releases become more predictable and controlled. And the final step, your nirvana step, here your delivery becomes fully automated, end-to-end CI/CD measured with the DORA metrics that I just talked about. Teams adopt these self-healing tests and AI-driven performance, and the quality, speed, and stability are continuously improved. So the key idea is progression along these levels and not perfection. So now I'm going to hand it over to Pradeep, who will explain this from a Datagaps perspective. We'll walk through how a CI/CD workflow performs in the Power BI environment with all the quality gates and deployment that I just mentioned. So Pradeep, over to you.
Yeah. So hello everyone. So morning. So thanks Anand for the overview. So building on what Anand just explained, right? So I will walk you through the demo of this CI/CD workflow. So before that, just let me start with the core problem. What we mostly we see in most of the Power BI environment today, right? So in Power BI developments are largely the manual reports are moved between the dev and UAT and the production by hands, right? With no reliable version control, right? A limited traceability and inconsistent the validations, right? So this means a small untracked changes can break a production report, and when it happens, we often don't know what changed and who changed it, right? And how to safely roll it back, right? That's our priority, right? Just to solve this, so we implemented a custom CI/CD pipeline for the Power BI using the PBIP file, right, and the Git. So every change is a version control here, right? So when a pull request raised, the CI pipeline automatically triggers a DataOps suite, a test cases, like the validating the metadata and data sets and the data flows. So without any manual interventions, right? So the quality gets ensured that all the tests are passed and reviewer approval is mandatory before any changes is matched. So once it's approved, the CD, the pipeline, deploy the changes automatically to the production. Yeah. So the outcome is a faster and safer releases, the complete governance with a full audit trail and a true DevOps discipline, like, applied to the BI. In short, so the pipeline to transform the Power BI from a risky manual deployment process into a controlled enterprise grade analytical platform. So next here, so this is the high level workflow, right? So this is simple CI/CD workflow, and it designed to be very easy to understand. Right? So let me walk you through this flow step by step. Right? So let me first, the development happens in the Power BI desktop file, right? So then the PBIX file is saved in a PBIP, the project files, so which convert the report into a folder structures, right? So there we have all the metadata changes, right? Yeah. So once the latest enhancements or the changes are completed, right, the developer manually pushes the the reports to the dev workspace or the UAT workspace here, right? So after publishing, the same changes through the metadata are committed to the Git repository here that you can see here, right? So now once the changes are available in the Git, so the developer raise a pull request or the PR. So this PR represent the movement of the changes from a UAT towards the production. Right? So as soon as the PR is raised, the CI pipeline starts automatically. At this stage, the data gap suite test cases that already mapped to the reports are automatically triggered. Right? So these test cases validate the reports, the data sets, and the related components, so that are executed into the UAT workspace. Here you can see. So all these test cases that are running into the UAT workspace now. So once the pipeline execution is completed, so the reviewer or the lead, right? So who will approve the changes, right? So that results, it will go into the main branch. right? So from this branch, so if once the pipeline is completed, now the review changes here. So now if everything is looks good, so now the validation passes or no issues are found, right? So now user can approve the changes, then automatically whatever we have in the dev workspace, right, whatever the report we have, so that will be moved to the production, right? So in summary, okay, if I want to tell in a summary, so this flow ensure that every change is version controlled automatically, tested in the UAT, reviewed, and then safely deployed to the production, so with a very minimal interventions, right? So with this, just we'll go to the demo. Okay, so now I created a simple report, right? So a very simple report, and see here you can see it actually. So this report is published into the dev workspace, and the same report so already published into the production workspace. So now as you see here, so both workers as the same one, right? So now what I will do is I will add a new visual to this report, which is in the dev workspace. So we'll go to the dev workspace and I'll edit it. So instead of, okay, so we are not doing changes in the any service here. So what I will do is I will download this file from the dev workspace, right? And this is the desktop file, right? So I have downloaded this file and I've converted this file into the a PBIX format, right? So now if you received a new enhancement request to add a visual to it, right? So that visual will add it into a desktop. Okay. So now we added a new visual here. So now what I will do is I'll change this one. So now the same changes, what I will do is I will first publish this file into a development workspace. I'll go here, in development workspace, I'll publish this file. Yeah. So it's done. So now if you see in the dev workspace, so now if I refresh it, so now whatever we have added the new visual, so that you can see in this dev workspace, right? So now we have added that visual is already coming here. So now next step, so what will go is I will move to the Git, right? So whatever we added as a visual or any data model changes, so that we'll see into the Git, right? So now added a new visual. So simply I'll comment this. This is done. So now I'm pushing these changes to the dev branch. Yeah. So now the changes are now available into the repository, right? So now I'll go to the Git one, right? Yeah. So now as per our CICD process, so next step is to raise a pull request, right? So now I'll go here and I will raise a pull request. So now here I'll select from where the changes has to go. So now I will select the prod one. So I'll be select a dev one, right? So from dev to prod, so we are going to merge the changes, right? So if you come here the below, so whatever the new changes, the JSON, so that here we can see it. So now we'll raise a pull request. Yeah. So now, so once the PR is raised, as I told previously, right? So automatically you see a pipeline is triggered, right? So we'll click on this pipeline. So the test cases that are associated with this report through the DataOps tools, so that start running automatically, right? So these validations are executed in the UAT workspace, right? Yeah, so now it's running, right? To save time, right? So I will go directly to show the outcome, right? So there are two data flows. I think if you're already using the suite, I think you will know this actually, how the pipelines or data flows are created. So the two flows is already created. So I will go to the first flow. We'll see actually what changes are there. So, so here you can see it, right? So in production, so we don't have that new visual. So in dev, so we have this visual, right? So we are showing the differences currently, right? So this is on the visual side. If there is any change between the visuals, right, between the two environments, so we are highlighting in the tool itself, right? So if there is any change in the data, I mean, if there is, if you have any data model level changes, right? So if we have that, so those, so we'll be showing here if there is any matched or unmatched. So those details actually we will be showing here, right? Yeah. So now whatever the pipelines, it's completed, right? So you can see it actually. The pipeline is now completed. So now here you can see it actually. Now, this step is handled by the reviewer or the lead. So the reviewer opens the validation report, right? Whatever we see here, right? So he will open that validation results in the DataOps suite and confirms everything looks good. Since all the checks have passed the reviewer, the approves, and merges the PR into the main or the production branch, right? So if everything is looks good, so now I will do is I will merge these changes. Yeah. So once the merge is completed, now the CD pipeline automatically deploys the changes to the production workspace. So let me refresh the production ones, right? So this is the production one. So let me refresh it. Now you can see here. So in production workspace, so that the new added visuals is already added. So whatever we have in the UAT, the same thing we got in the production as well. So this is the like, you know, the complete Git based CI/CD process. The biggest advantage here is what we are report changes happens, right? That test cases are automatically triggered, and the validation happens in UAT, and the deployment, the development to the deployment, to the deployment to the development to the production is automated, and there is very minimal manual movement, and there is a minimal risk here, and we have a full traceability. So this makes the Power BI the deployment reliable, and it is very scalable, and it enterprise it's ready actually. Thank you, everyone. Over to Puja.
Thank you, Pradeep. Let me just share my screen. All right. So, thank you. That Pradeep shared an incredible demo, went through a couple of flows that he mentioned. So this is where Datagaps plays a role in all the test case validations that you see. It's an automated process, as we mentioned. And it follows, what you have in your local machine, what you have in the Git repo, and what you have in Microsoft Fabric, the workspaces, etc. So please do take a screenshot of this if you're, not familiar with this process. But yeah, and then let's conclude with some checklists and next steps. So the here is, as you think about BI testing at scale, through this whole CI/CD process. So everything starts with identifying your key reports and business KPIs. So these dashboards drive the decisions, the compliance, the visibility. And once we validate those foundational elements, the report metadata, the layout consistency, the filters, the semantic models, the logic of the measures. So a clean structure reduces any kind of downstream defects. So the next is report data validation and comparison. So we verify what user sees matches the source data. This includes all the filter validation, the extract checks, and any kind of regression testing across dev, test, or prod. Finally, there's this whole business logic and performance. So KPIs must follow predefined business rules and any kind of cross KPI validation to catch the logical problems. Performance and stress testing ensure that the scalability happens under real user loads. And then security is critical. So you have role-based access and group permissions that must be tested. And there are some questions on that, and I'll get to them. And supporting is all this enablement and efficiency. And so this framework shifts the BI testing from reactive firefighting to more disciplined data ops, bringing reliability, the speed, and confidence in your Power BI deployments. So the core message is Power BI deployments must be modernized. The traditional PBIX-based workflows create risk because they rely on a number of manual steps and the process is fragile. And by treating these BI assets as code, using this PBIP format, we unlock the CICD capabilities and bring more discipline into this BI delivery process. And once CICD is enabled, the stability improves. A more structured pipeline reduces these release errors, and deployment automation replaces this manual publishing. And automation alone is not enough. We must shift the testing to the left by adding these automated quality gates early in the deployment process. So to development specifically, so that issues are caught before production. And then you have this layered testing strategy with the validating the data, the business logic, the visuals, the performance, end to end. You're doing this, and your success is measured by faster deployments, fewer failures, and quicker recovery. So what you need to do as a call to action is assess your current maturity. We talked about the whole waterfall of different levels. You move from reactive firefighting to a more managed predictive model or proactive model, and you integrate this automated validation into your DevOps workflows and add those quality gates. And then if you, and Pradeep could probably help you, but if you want to see it in action in a live demo with Datagaps, where you're automating the regression, all these different tests, you can scan this QR code that we have. And so now let's take some questions. And you can reach us at contact@datagaps.com. And you can scan this QR code for a 2-week trial where you can test our product. So now we'll take a few questions.
Hi, Anand and Pradeep. So the first question that we have.
Yeah.
Do you recommend feature branches and workspace for them with a central DEV main branch and workspace?
Yeah. So maybe I should take a shot at it. So so most teams use feature branches in Git, but they don't need a separate workspace for each feature branch. So a practical setup would be you have one shared dev workspace mapped to the main branch, and then you have the feature changes feature branches rather for all the changes and pull requests. So you use the CI checks on every pull request and deploy only after the merge. So you create a temporary workspace only when you truly need it, and that way you are having this isolated testing, and you don't have separate. You're separating the sensitive experiments, and you're separating the work using the featured data sets, and you're controlling the deployments. So this keeps all the administration overhead low and preserving the safety. Do you have more questions? There definitely should be more. Yeah, I see that. So the question is, how do you solve this single authentication session, which impacts these multiple developers to own their comments in the same workspace, right? So the key part is you should avoid sharing one GitHub login, right? The clean fix is to have each individual identity and a controlled development identities. So each developer commits using their own GitHub account. So every change has a clear audit trail. So for any kind of deployments to this Power BI, you use like a service principal that DevOps owns. And if you work in one workspace, limit who you can deploy and require pull request and block any kind of direct publishing. So this separates the authoring accountability and the deployment automation. Yeah. So that's a pretty good question. Power BI's usage metrics isn't designed for any kind of long history of a year. So you need to export the activity log and store it somewhere else, maybe in a data lake. And you use Microsoft Purview, for example, to audit those logs and set any kind of retention policy that you have of up to a year, you said. So you can use Microsoft Purview. Yeah. So that's a good question. So if you have a one model or multiple reports, and so for deployment you want to use these fabric deployment pipelines and selectively deploy. So you can pick only that one semantic model and the two reports. You can't do it for all 50. You choose your reports and deploy just those to the next stage. So you can also select the related reports, so any kind of dependent report or model move together and they don't break the reports. So this gives you a reusable release bundle without creating a new workspace. And you can also do this with Power BI pipelines, REST API, using selective deploy so that you don't break anything. Yeah, so the user acceptance testing, Pradeep, do you want to answer this? Or maybe let me do this. User acceptance testing, this is like a hard gate where all this CICD process builds and validates the PBIX changes. Then you have continuous deployment that deploys automatically to the user UAT workspace. And you freeze the exact release candidate where you commit, tag and commit that. And then the QA testers validate on their own schedule. and then the pipeline pauses until this manual approval process is recorded. You can use Azure DevOps or GitHub environment for the approvals and the ticket sign off. And after the approval, the same tagged artifact gets promoted to production so that there's no republishing. So you add a timeout or a rollback rule and require evidence for the approval. So this keeps all the UAT environment and the production synchronous. But you're auditing the thing. So what happens if the CI pipeline fails? Yeah, go ahead.
Yeah, let me take it this. It's a good one. That is very important point. Like so in our setup, so the CI pipeline act as a quality signal, not an absolute blocker. So even if a pipeline fails, so the reviewer or the lead still has a authority to approve the pull request, but only after the understanding why the failure occurred. So then only you can go and approve it.
Great. Yeah. I think we are running out of time, and this is all the questions we have. There are a few more, but we would like to pause at this moment. Thank you for attending this webinar. You have the QR code there. We have a lot of documentation on Datagaps, and we also have a 2-week trial that is extensible to another period, so that you can play with our product, understand this functionality, and use it in your environment. Do contact us so that we can walk you through everything. We have our support team here to help you, but the first stage is getting in touch with us. So thank you for staying engaged. Lots of great questions. And we look forward to hearing from you. Thank you.
Thank you, everyone.